and welcome to lesson 6B. Today we will be applying these integer operations that you've been learning all week. So today students will be able to apply integer operations to real-world situations and use the commutative property. Notice that's commutative. There's no N in there, commutative. Language objectives. Students will be able to write answers as complete sentences. And this is important for many real-world problems like finding the charge of an atom. All right, so the commutative property, like commuting back and forth from work and home, allows us to change the order of numbers in addition or multiplication problems. So with our integers, remember we can write all subtractions as addition problems, so we can switch the order there. So -1 plus 2 is the same thing as 2 plus -1. 5 times 2 is the same thing as 2 times 5. It's like going to work and then going back from work straight home. It allows us to add in any order we'd like, and this is what's important. This allows us to add in any order that we would like to add in, so if there's nicer numbers to put together, we can put those together first. So we can use this little idea of adding in any order to find each sum even when there's a long list of numbers. So the first thing we're going to do is combine all of the negatives together and then all the positives, and that's really going to help when you've got a long list of numbers. All right, so again, let's make a little note there. Combine all negatives, then all positives. So we want to kind of group together all the negatives and all the positives. Sorry, I wrote kind of small there. Combine all the negatives, then all the positives, and then we can go from there. So in number 1, we see -12, -6, +15, and -2. So if we combine all these negatives together first, we know they're all the same sign, so we can add all those together because they're all going the same direction, and then we can think about the positives. So -12 and -6 together would be -18, and -18 plus 2 more negatives would be -20. And so we can write all of those negatives together as -20 and then add the 15. Now we can think about how many positives we have, how many negatives we have, and which one we have more of. So in this case, we have more negatives. And so we know if we crossed out all those 15 zero pairs, we'd be left with 5 negatives. And then it says explain why the sum is what you say. So -20 plus 15 equals -5 because we have 5 more negatives than positives. 5 more negatives than positives. All right, and I'm not going to be writing that out for every single one, but this is the reason why. All right, let's look at number 2. We have 1 plus -3 plus 2 plus -10. I see that this is negative and this is negative. So I'm going to combine together the negatives and then separately combine together the positives. So I like to underline and circle. It's just easier for me to see that way. If it's easy for you too, go ahead and do the same thing. So 1 plus 2, I know those are my positives, so that gives me 3. And we can write 3 plus all of our negatives as long as we put a parenthesis there. So -3 and -10 together would be -13. And then it's a simpler problem to... Okay, so now we have 3 plus -13. We have 3 positives, 13 negatives. We definitely have more negatives. And how many more do we have? We have 10 more negatives than positives. So that would be -10. Remember, when they're different signs, we do subtract the numbers because some of them will cancel out. All right, on to the next one, number 3. Oh, wow, look at this one. So this one's showing a whole lot of subtraction. But remember, we always write subtraction as adding the opposite. That's what we did yesterday. So we're going to go through and write in and add the opposite everywhere we see a subtraction sign. So add the opposite, add the opposite, add the opposite, add the opposite. Okay, so notice those all became positives. So what this really says is -7 plus +9 plus +2 plus +1 plus +5. So all of those are actually positives because it was the negative weirdness, the weird thing. So the only negative I have left is this -7. So I'm going to bring that down, -7 plus all of these positives added together. Well, remember commutative property, we can add in any order we'd like. So I see 9 and 1 first because I know those add to 10. 10 plus 2 is 12, plus 5 is 17. So this really says -7 plus 17. Now it's a simpler problem to look at. Which one do we have more of? Let's see, we have 7 negatives, 17 positives. We definitely have more positives. Those 7 are going to cancel out, and so I would be left with 10 positives. All right, last one of these, and then we'll look at these application problems. So let's look 40 plus -13. Plus is fine. We don't have to change a plus, but we do change a minus. So remember, all subtractions become add the opposite. So that becomes plus +29. And back here, there's another subtraction, so I'm going to add the opposite. So I'm going to write that as plus -16. I'm going to write it that way. Now we combine all of our negatives. So I see right here there's -13, and right here there's -16, and that's all I have for the negatives. So -13 and -16 would be -29. And then our positives, we have +40, and we have +29, and so those together mean I'm adding 69. Now we can look, how many more do I have? Do I have more positives or more negatives? Well, I definitely have more positives. So my answer is going to be positive. And when I take out those 29, I would be left with 40. Now, if you needed to do any of that work to the side, that's fine. You would just write your work to the side, 69 minus 29, and that gives us 40. So if you need to do your work over there, that is perfectly okay. All right, so that would be our answer. So anytime you have a list of a whole lot of integers, you combine together the ones that are similar. So all the negatives go together, and then all the positives go together. All right, so now the main objective of the day, applying integer operations to real-life situations. In this case, we're just going to be looking to see if each little sentence, each little phrase gives us a positive number or a negative number. So this one starts, Jenna has $125 in her account. So she starts with a positive 125. She deposits $45. Deposits means she's adding in there. So I'm going to write plus 45. And withdraws, withdrawing money means taking it out. So that means a minus 80. Later she returns to withdraw, so take away another $40. And deposits, that's a positive one, deposits a check for $250. All right, so that's how we would write out a whole number sentence, a numerical expression, because notice it says write a numerical expression. That's our numerical expression, and now we solve. Well, I see some minus signs, so I'm going to change those to add the opposite, add the opposite. And so I can actually see which ones here are positives and negatives. So I see this is actually a negative 80 and a negative 40. I don't have any other negatives, so I combine those together, and it's negative 120. Plus, I have a whole bunch of positives. So we have 125 plus 45. If you need to do that to the side, that's okay. 125 plus 45. All right, well, that's going to give me 170. And then I've got another 250 over here, so I'm going to add 250 to that. Let's see, 0 and 12 carry the 1. 2 plus 1 plus 1 is 4. And so that gives me 420 positives. So she put $420 in her account, but then she took out 120. So did she end up positive or negative? Do we have more positives or more negatives? Well, we definitely have more positives. So over to the side, if you need to do that, we're going to be taking away 120 from 420, and we get 0 and 0 and 3, and so that means she would have a positive $300 in her account. All right, let's try the next one. Number 6, last week Julio made deposits. Okay, deposits are positive numbers of $84 plus $19 plus $29 into his checking account. He then wrote checks. So if you write a check, he then wrote checks. If you write a check, that's going to take money out. He wrote checks for $53, over here, $53 and $38. What is his overall change in Julio's bank balance or account balance? So this is how we would write it. When you write a check, it takes money out. All right, add the opposite, add the opposite. These two are negatives, these three are positives. And so we combine those together separately. All right, so I see 84 plus 19 plus 19. 84, 19, and another 19. Oh, sorry, 29. 84, 19, and 29. All right, so we're adding those up. So let's think. 9 and 9 is 18. 18 and 4 is 22. Carry the 2. 8 and 2 is 10. Plus 1 is 11. Plus 2 more is 13. So that means I have 132 for the positives. Plus negative, over here on this side, we combine together all of our negatives. 53 and 38 combined together. 8 and 3 is 11. Carry the 1. 5 and 3 is 8, plus 1 is 9. So that means I'm taking out $91 from that account. So we have 132 positives, 91 negatives. We definitely have more positives. And so we have one more little subtraction to do. We have 132 minus 91. All right, 2 take away 1, that's fine, that's 1. I cannot take 9 from 3, so I think of this as a 13. 13 take away 9. 13 take away 9 is going to leave me with 4. All right, so that means I would have, or Julio would have positive $41 still left. Okay, because there's more positives than negatives. He put in more money than he took out. All right, let's go to the back of this. There's a whole lot of these. Let's see what we can get through in the next couple of minutes. All right, Tom left school and walked 5 blocks east. All right, east, if you know your directions, never eat soggy waffles. What am I talking about there? Remember, north, south, east, west. Never eat soggy waffles. Those are our directions if you've learned this in geography. So there's our directions. We need to know those. So Tom left school and walked 5 blocks east. East is to the right, so I'm going to call that positive. Positive 5. Charlie walked the same distance west. So that means he turned around and walked left 5 blocks. How far apart were the two friends? Oh, they want to know the distance between them. All right, Tom left school and walked 5 blocks east. All right, so if we're looking at the difference between them, we're not going to be adding there. We're subtracting a negative 5. And this one would make sense to draw a number line. So let's look at a number line. If school is at 0, Tom left school and walked 5 blocks east. So Tom left and went to the east. Tom's going to end up over there at positive 5. Charlie walked the same distance, but west. So Charlie is over here at negative 5. Charlie is way over there. Charlie's over there. How far apart are the two friends? So we're looking at the difference between negative 5 and positive 5. Well, if we count all those steps, or if we're thinking distance here, we could add these together. But if we count all those steps, there's 5 going that way and 5 going that way. So it's the difference between 5 and negative 5. We would add the opposite, and we would get 10. So they are 10 blocks apart from each other. The friends are 10 blocks away from each other. From each other. Sorry, that got a little messy right there. From each other. Okay, so that's going to be it for today. We're going to be looking at a few more of these as we go through the week. Don't forget about the exit ticket and ask me if you have questions. Have a good day. Yay, math.